Hello, everyone. Thanks for joining us today, and welcome to our webinar, 3 Cutting-Edge Geospatial Technologies to Help Your Business Today. My name is Jody Lee, and I'll be the moderator on this webinar. You can go to the next slide. I'm excited to be joined today by Barrett Sather and Brian Justice, both program managers on our solutions delivery team at Harris Geospatial. Barrett has been with the company for 7 years and has experience in remote sensing, algorithm development, spectral analysis, satellite imagery ingest and analysis, and scientific programming. Brian has been with the company for 20 years and has experience with managing large projects related to geospatial software analytics workflows. So just a couple housekeeping items before we get started. I've muted the phone lines for all attendees, so if you have any questions at any point during the webinar, feel free to enter them into the questions chat box, and we'll try to answer as many as we can at the end of the presentation. We are recording this webinar, and we'll have it up on our website at www.harris.com in the next couple of days. We'll also email you a link to the recording, as well as the slide deck and the Q&A sheet. And you're welcome to share it with your colleagues. So without further ado, I'm going to turn things over to our first presenter, Brian.
Hello, everyone. Today we're going to go over just a quick overview of Harris so that you kind of know who we are if you're not familiar with us, and an overview of the solutions delivery team, which both Barrett and I work within. We're going to be going over 3 trends today that we see a lot of activity in the last year related to geospatial data processing, and then of course questions and answers at the end. Harris Corporation is a global technology leader providing electronic warfare, avionics, air traffic management, space and intelligence systems, and weather systems to customers in more than 100 countries. The headquarters is based out of Melbourne, Florida, and we have about 17,000 employees worldwide, with 7,700 of those being engineers and scientists. Harris has 3 segments: the Communications System Division, Space and Intelligence Systems Division, and Electronic Systems Division. We fall under the Space and Intelligence Systems, which in the simplest terms provides broad sensor and payload expertise, extensive ground system development, and proven high volume processing capabilities. Within the Space and Intelligence Systems Division, we're the Geospatial Solutions business. Our expertise is applying advanced geospatial technology to solve hard problems. Organizations from across industries rely on our in-depth knowledge of advanced geospatial analytics, machine learning, and remotely sensed data to make better decisions. The Harris Solutions Delivery Team has a vast experience in this industry. So basically phenomenologists. They're all of our developers are phenomenologists, algorithm developers to help solve problems that you're looking at. We also have experience with the technology used in this industry, including deep learning, other geospatial tools besides the tools that our company makes, as well as software development experience with experience with many different coding languages and experience developing both desktop and enterprise workflows. Okay. The first trend we're going to go over today is deep learning. I'm sure most of you have heard about deep learning. Over the last almost decade, not quite a decade, this technology has improved vastly. You can see back in 2010, this is error rates for using deep learning to do basically feature extraction. And you can see the error rates back in 2010 were very high. Today we're down into like less than 3% error rates. I will say that depends upon the targets you're looking for and how well you develop the solution. But this technology is increasing year over year over year. The other good thing to point out is, as you can see right there between years 2014 2015, that's where a human analyst sits as far as accuracies. So deep learning is starting to even achieve accuracies higher than a human can achieve. This technology is being used in almost every industry. Of course, today we're going to concentrate on how deep learning is used within geospatial data processing. But you can see the different kinds of technologies that are being used today. So what is deep learning? So deep learning is actually a subset of artificial intelligence, which machine learning is a subset of, and deep learning is a subset of machine learning. It's a system that can be trained, basically. There's no coding involved in trying to create what we call a model to, for example, perform feature extraction. It is based on a set of algorithms that create a high-level abstract representation of the target. We'll go into more of that in the next slide to kind of give you an example. But it works on any type of data as well. So whether it be hyperspectral, multispectral imagery, 3D point clouds, even metadata can be fed into the system to try and learn how to find an object. So on the right here is an example of how the system will learn to recognize objects. So I'm going to start at the bottom because it's easier for me to explain. So at the bottom we have a whole bunch of faces. So that is the target we're trying to find here is faces. What the algorithms do is break that down into subsets or components of a face. And so you can see the next block up shows eyes and ears and noses. Those are the subcomponents of a face. Those subcomponents are broken down farther into curves, lines, textures, colors, shapes, and compound shapes. And eventually what's abstracted is a representation of what a face looks like. So that's basically how deep learning works. Typically it is supervised training. You can do unsupervised training, but it is a lot more work to do an unsupervised training project than a supervised training project. Typically the more training data, the better. So the more examples of targets that you have, like over on the right here, we have a whole bunch of this is a standard data set used for testing, a whole bunch of different pictures of cars, right? So the more cars you have, the better. The training data must be representative of what you're trying to find. So if you're trying to find cars, don't just feed it pictures of white cars, because all you'll find is white cars. You need to give examples of all sorts of colors and shapes of cars to really represent what a car looks like. Let's see, you also feed it non-target data. So what you're trying to do is to teach it what is a car and what isn't a car, okay? And we also feed it what we call confusers, and that is things that look like a car but aren't a car. We do that so that we increase accuracies. You can achieve success even with smaller training sets. We've done with as little as 100 samples, 100 examples of, for example, a car, and have come up with some pretty good models. But that is purely dependent upon the complexity of the targets you're looking for, as well as how unique it is in nature. So things that look like other things, you're going to have to use a lot more images to find them. Basically, we've developed a lot of experience in creating these training data sets to find targets. Here's some examples of what we've been able to accomplish in the solutions delivery group. First one is just simple target extraction or target detection. So you can see kind of the list there on the left of things we've been able to find, and some examples of finding planes and finding ball fields. We use these two examples because they're very descriptive of hard problems, meaning planes and ball fields are very complex objects. They're not just simple objects. They're made up of a lot of different pieces, and we can still abstract them. You can see in the lower image with the ballparks, they're very complex objects with infields, outfields, bases. all those things. And you can see kind of on the lower part there, there's just a little mini infield that wasn't selected as a target because it's not a full ball field, right? So that's how accurate this technology can be. On the right, we have an example of using deep learning for land cover classification. The first image on the top there is the source data. The second one was created using best practices of spectral processing. And then the bottom one is an example of a deep learning land cover classification. And you can see there's a lot less clutter, a lot more accuracy in the bottom image than in the middle image there. We also use deep learning capabilities to do what we call scene detection. So instead of looking for an object, we're looking for a condition within the image itself. This is an example of a product that Harris sells called Helios, and it uses traffic cams to actually detect the conditions of the road. So you can see here that we were able to identify when a road is wet and when a road is dry, other conditions as well within that product. On the right is another Harris initiative to be able to create synthetic training data. So this program realized that a lot of targets that you're looking for are not readily available in imagery or sample imagery that you could find today. They may be targets that don't exist or so few that you can't find pictures of them. So we've been able to create synthetic images, training images, in order to train a deep learning model to do feature extraction. Another example here on the left is not imagery. This is LiDAR. This is a LiDAR point cloud. This is an example of a project we did where we were trying to find assets of a railway. And you can see this is a very complex image with a lot of power poles, power lines. This is obviously an electric train. And what we've been able to find in this image is the signals. And you can see they're denoted by the blue line that goes up to the top there. Very high accuracies, even in LiDAR imagery, 92 to 96% accuracies in this project, finding those signals. Another use of deep learning that we've used in projects is to create thematic maps. So we're trying to break down, in this case, another railroad picture. We're trying to break down to find the different materials within an image of a railway. The image there on the top is one of the tools we've developed to help create training sets very quickly. It allows us to label the different classes of materials in the image really quickly and be able to create models of very high accuracy. So at Harris, we use this technology, deep learning technology, to help solve real-world problems for our customers. We've been working on this technology for over 6 years and have invested millions of dollars in this technology. We have a very large team at Harris doing research and development on different deep learning techniques, as well as other teams to go out and actually develop and deploy systems for our customers. So lots of investment here. The solutions delivery team here can help you with labeling training data sets, choosing the correct architecture for deep learning models, creating workflows around those models with preprocessing and post-processing to actually create products that our customers are in need of, as well as any kind of optimizations to make it run as fast as possible. And with that, I'll turn it over to Barrett. He's going to go over the next trend.
All right. Hello, everybody. I'll start off with trend number 2, which is UAV analytics. And really, this technology has really taken off in the last few years. A lot of it's due to the fact that the technology is much more available and less expensive. So a lot more people are turning to UAVs to get the data that they need to solve their problems. We have experience on our team doing UAV analytics for agriculture, utilities, and transportation. And we can help with analytics to solve a broad range of problems, and that can include mosaicing, color balancing, co-registration, target or feature detection, and even change detection, and then spectral classification, which is one of our legacy bread and butter techniques that we've been good at for a very long time here at Harris. So before you get the data, though, something that we can help you with before we even start those analytics is to help you with not only what to process, but what to collect before that processing begins. So we can help you with your capture technique and getting the data that's going to make you successful down the line when we actually get to that processing side. So we'll make sure that you have enough imagery to actually cover your full area of interest. We'll make sure you have enough overlap so that the stitching goes well. We will make sure that you have the right bit depth, the right dynamic range, contrast, all of those things to ensure that you're able to get clear, informative images and then actually be able to detect your target or whatever your analytic is going to require. So what I'm talking about there with sensor settings and getting those settings correct is that you can actually oversaturate or have too much contrast in an image and wash those out, or even get under saturation, which could lead to having not very much detail in an image. So it's very important to make sure that for your target and for your application, you're actually collecting data that's going to provide good enough resolution and good enough saturation and contrast so that you can actually find those things in the imagery. So that's something we can help with as well. Once the data is actually captured and the capture technique has been followed, then when you have the data, the first step is often to do some sort of pre-processing to that so that you'll have more accurate results in the downstream analytic. That can include things like atmospheric correction, resampling, calibration, photogrammetry, or even just metadata validation to make sure that you have the right GPS information and the right pointing information to make sure that the analysis downstream is going to go smoothly, and that's something we can help with as well. After pre-processing and getting your pixels in order, making sure that everything is all spectrally calibrated, the next step is often to take the many UAV images that you took over a single collect and mosaic those together and co-register them onto a map so that you can answer the question of where in my imagery is this feature actually located and give it geotagging or some sort of meaningful physical location on the globe. So we have experience using a variety of tools like NV1 button, NV Pix4D. We're fairly tool agnostic here, and we help you find the right parameters as well as the best solution for your stitching. And it's a very unique, every case is unique in this. So it often takes a different tool or different parameters to do that. So once you have a stitched, pre-processed, good capture technique, and your data has come into the analysis part, I'd like to show some examples of what we've done for that analysis. So the first one is precision agriculture. We have experience extracting a whole bunch of different features from agricultural fields, including the crop health, crop count, crop size, and then even field stress or crop yield, and things like nitrogen content. You would need a hyperspectral sensor for or at least those bands where you can detect that actual feature in the spectrum. And do note too that I'm showing here a orchard, so it's more of a permanent crop, but we also do annual crops, so we can do corn, soybeans, any crop that you want to analyze. We have different analytics for both those permanent and annual crops. Another example for UAVs that we've done in the past is asset inspection. So in this case, what we did is flew a UAV up and down a wind turbine, and the UAV imagery that comes back, we analyze that using deep learning technologies to look for damages on those blades, and then report back to a user, hey, this blade is damaged, it may need to be repaired or replaced. So in this project, we helped out with the capture technique, We helped out with getting the right sensor specifications, and then Mosaic, that UAV imagery, you'll see the image on the right there. That is a mosaic of many different UAV shots onto the blade plane, and then we do the automatic anomaly detection of the blade. And of course, once that's done, the dissemination of that result actually happens and goes out to those wind turbine owners or engineers. Okay, so that wraps up for Trend 2. So on to Trend 3, which is enterprise and cloud computing. This has really taken off over the past decade or so as well. And as this technology has evolved, we've evolved along with it. And we're now experienced in moving customer solutions to the cloud. There's a lot of different reasons that you would want to take a desktop application or an application that's just on physical hardware and make that into a cloud solution. Definitely hardware and maintenance upgrades, maintaining backups and storage, but also just running compute hours and saving on energy bills. It also makes it so that once you go to the cloud, your application is now accessible from anywhere. So that can cut down on bandwidth issues and accessibility issues. And really, it's also a great performance enhancer because you can spin up and spin down many machines in order to get the performance and throughput that you need. So if your current system's not meeting your needs, we can definitely help you tailor a solution that will work for you. And part of that is that we'll not only just develop the solution, we're also experts in actually defining a solution too. And part of that is that we'll first just work with you to understand the problem and make sure that we are identifying the right data capture and the right capture method, much like we do for UAVs. We select the right hardware and right software, and we really help you build out and tailor this solution to meet your needs. And another part of that too is scoping out the solution. We make sure that the solution is going to fit within your time frame and your budget to meet your needs. So oftentimes what we'll do is proof of concept to make sure that the algorithm is going to run just the way that we want to, and make sure that that algorithm is in a good place before going to a full production mode. And then we also do multi-stage projects, which help you with ensuring that your deliverables are coming out on schedule, as well as maintaining that project and budget on time. So that's definitely part of building out these enterprise apps. Our software developers, once we go to the development phase, are fairly tool agnostic. We just use the right techniques to get you what you need for your solution. This includes data storage, search and discovery, and then once we get to the analytics, we do the pre-processing before and then the post-processing after. We can help with generating final products and then also even disseminating that information back out to your users, whether that's a database or a web front end or some sort of other solution. So we really do customize with the tools that are needed in order to get a framework that meets your needs in the cloud. And the last piece of that, once the solution is actually developed, is to actually deliver it. So we can help with the last phase as well, and that includes the deployment. We can come out to your site to do a deployment. We can do over-the-shoulder deployment. We can do installation instructions and installers to ensure that your deployment goes as smoothly as possible. Once that's actually deployed, we can also help train you up on the system. So that could include some sort of fast start, sending someone out to train you up on the system. And it also includes custom courses if you have many people, or even creating custom training documentation for your actual system so that you can train users now as well as in the future as your system evolves. And finally, we can support you through the process. Once it's deployed, we can continue to add new features as your solution grows and your needs change as a business. We can be on-call technical support during that time to make sure that your solution grows with you as you need and continue to evolve. So another option too, though, is if you don't want to either stand up your own private cloud or host your own hardware, we also have a hosted solution here at Harris where we've stood up our own hosted service So this is an automatically scaling service that can scale up and down to meet user demand. So whether we're running on 1 user, 10 users, 1,000 users, it'll scale up and down to meet that demand. There's no need to be an expert in cloud computing if you go this route. There's no hardware or software that you need to buy because it's all just here at Harris, and you just pay for what you use. So a sampling of the algorithms that we actually have hosted on the solution right now are below, and I'll give a moment to just take a look at those. But they're NV solutions, they're deep learning solutions, there are all sorts of different algorithms that we can put up onto this cloud infrastructure and then run it as a service. So when going to the cloud, we at Harris, we can help with the entire process. And this is really true for all of our projects here in the Solution Delivery Group. We can help with the definition and the scoping, as well as deployment and training and support. We're not just a development shop. So we really do take the time to understand customer problems and take them end to end and make a true end-to-end solution. So to wrap up, we had our 3 trends, which was deep learning, UAVs, UAV analytics specifically, and cloud and enterprise solutions. And our solutions delivery group here, we have industry expertise across many industries and can help with many different kinds of solutions. We can help with software design and development, commercialization services, IDL and NV custom applications, algorithm development, and deep learning solutions. And all of those could be either desktop, cloud, or private cloud, or hosted solutions. So that is what I have. Thank you, everybody.
Great. Yeah, thank you, Brian and Barrett, for the informative presentation. So at this point, we're going to address some questions that have come in. As a reminder, you can send us a question by using the questions chat box on your GoToWebinar dashboard. With that, we're going to get to the first question. Can deep learning help me find building outlines?
I guess this is Brian. I'll take that one. So, the answer is yes. Now remember that deep learning is really at its core a feature detection type of capability, and so in training a model, you wouldn't be looking for a house; you'd be looking for the edges of a house, right? And that's what you could do to train to find building outlines, and then of course. Of vectorizing the outputs of the deep learning algorithm to do the building footprints. We have experimented with that here and know that it's possible. So if you're interested in that.
Great. Next question. I have a video camera on my UAV. What sort of analytics can you do on video?
Yeah, so video is a kind of different data format that we have dealt with in the past. It really just depends on your camera, especially. If you have something like a GoPro where you have a fisheye lens, it's going to be harder to answer that question of where because of the warping that occurs in the image. It's going to be harder to get coregistration or any sort of actual target where it actually is on the ground. If you have that sort of distortion, but if you have a video camera that's taking raw pixels and then bringing that back to the video card, we can take that data file format and perform analytics on it, whether that's on single frames or on the video itself, as it's just another video, it's just another data stream. We could feed that into a deep learning model or another analytic as needed.
All right, great. Next question. I have my own code base and deep learning tools. Can you help me deploy them to a private cloud?
Well, I guess I'll start with that one because the deep learning.
Sure.
So the answer is yes. We have an experience with a lot of different deep learning tools. We're very familiar with what's out there and using those different tools. So I'm sure we've probably touched something similar to what you're using to do the deep learning. With respect to deploying in the cloud, we certainly can help there because like Barrett was saying, we can help with any stage along that line. So even if you already have pieces of the analytics built, we could certainly help you with the rest of the project of the data acquisition, the pre-processing, the post-processing, the final product generation, the getting it hosted in the cloud and solving all those issues. We have a lot of experience there and can certainly help you.
Great. Next question, is IDL support on AWS Cloud?
I mean, I wouldn't say that there's an official IDL support on AWS Cloud, but if you spin up an AWS instance in the cloud, depending on your architecture, IDL is cross-platform supported. So whether you have a Linux instance or a Windows instance, we can set up IDL on that cloud infrastructure. Absolutely, yes.
I will also add too that there is specifically IDL engine, so it's a headless version of IDL that runs on top of what we call our Geospatial Services Framework, which is really a job queue and an optimizer for running enterprise-level apps. So you can sit IDL on top of that and have as many instances of IDL running concurrently that you want to really speed up processing as well. So that works really well in cloud environments.
Okay. Next question. I'm working on HSI data for planets phenotyping. I don't know how you say it.
Using hyperspectral data to do plant phenotyping, if I understand the question correctly. So yeah, that's something that we can do in NV. That could be something that could be an enterprise application or desktop application. NV is extremely good at hyperspectral feature detection and those things. Phenotyping is a classically hard problem. I would be curious to hear more about it. So if you want to reach out to us after this, I would be happy to answer any questions.
All right. And then what's the best solution for HSI and spatial resolution? Or does photogrammetry have a chance of closing the gap on LiDAR with regards to vertical axis spatial resolution?
So right now, LiDAR really is the ultimate for spatial resolution. And I'm assuming that you're talking about like stereo imagery where you can derive point clouds, and do measurements within those. Those still are not as accurate as pure LiDAR, just because there's still noise, still rounding errors in the math as you extract out those points. LiDAR can be still a lot more accurate.
Great. Next question, is the deep learning labeling tool a part of NV desktop, such as collecting ROIs, or is there additional, more automated labeling not included in the standard NV 5.5.1 release?
So the current labeling tool that we've developed is not part of NV. It is using NV, it's built on top of NV, but it's mainly used internally for projects that we're working on deep learning solutions with customers. But we'd certainly be willing to talk to you about getting you that tool. And so if you want to contact us after the meeting's over, we'd be happy to talk to you about acquiring that tool.
Great. So that's all the questions we have. With that, we're going to wrap things up. We appreciate everyone's attention on the line, and thank you again, Brian and Barrett. If we didn't get to your question, then someone will follow up. As a reminder, we did record this webinar, and we'll have it up on our website at www.harris.com in the next couple of days. We'll also be sending all registrants the recording of the webinar and the slide deck. You're welcome to share it with your colleagues. So thank you, everyone, and have a great rest of your day.